Let us switch over to problem number 12. A stone of mass 0.5 kg is attached to one end of an aluminium wire of length 0.8 meter and diameter 0.7 millimeter suspended vertically. The stone is now rotated in a horizontal plane at a rate such that the wire makes an angle 85 degrees with the vertical. If Young's modulus of the wire is 7 into 10 power 10 Newton per meter square, sine of 85 degrees is 0.9962 and cos of 85 degrees is 0.0872. The increase in the length of the wire is how much? That is actually the question given, and four options are mentioned this way: 1.67 into 10 power minus 3 meter, the first option; 6.17 into 10 to the power minus 3 meter, the second option; 1.76 into 10 power minus 3 meter, the third option; and 7.16 into 10 power minus 3 meter, the fourth option. What exactly he is just giving us? Try to just understand the question carefully. There is a string like this to which a mass m is attached, and according to him, this mass is now rotated in a horizontal circle this way. This is the radius of that circle as such. And of course, this is the way he is just talking about the body is being rotated. And when you consider this body is here, it is now making an angle 85 degrees with the vertical. That has been very, very clearly given in the problem. So when you just talk about this mass as m, its weight will be acting downward. And we know pretty well, if I just take this is the string, there will be stiffness in the string which is to be called tension in the string as such. That always will be towards the point of suspension of the string as such. If I just take the component of tension along this direction, this being 85 degrees, this now becomes T cos 85 degrees. And we can understand well, its component along this direction will now be T sin 85 degrees. But when you imagine the body is just moving in a horizontal circle as given in the problem, certainly this T sin 85 becomes the centripetal force acting on that body. That now should be compensated by mv square by r, or you can even write mr omega square, which of course is going to be the so-called centrifugal force that is acting on the system. So when you talk about this one, you can write that unless these two forces are compensating each other and these two forces are compensating each other, it's not possible for this body to move along the same circular path. So what are the equations we can write from this figure? Look at carefully. T sin 85, that now is going to be mv square by r. Exactly in the same manner, T cos 85 must be equal to its weight, that is mg. And what is the question he is asking officially? What is the increase in length of the wire? So suppose if you take that increase means elongation, is it not FL by AY? You can certainly understand what is what out of that. L is length, A is area of cross section of the wire, and Y is its Young's modulus. F is going to be the tension that is in the string. That value of tension now I have to calculate from these equations. So let us take this equation first. If you want tension from this, T can be written as mg by cos of 85. What is mass of the body that has been attached to it? You look at it is given 0.5 into G value is given 9.8, of course not given, we know that value very much. But cos of 85 value he gave in the problem. What is that value given? 0.0872. 0.0872. If you simplify this value, you will be getting around 56.2 Newton. That is the value of tension the body is going to have, or the string is going to have, when the body is at this position, or when the body is just moving along the horizontal circle. So what we can understand now, taking this value as the force applied here, 56.2 into, what is the value of length? Of course, length is given as 0.8 meter. So you can write this 1.8 meter by pi r square. What is the radius of cross section of this string given? Diameter is given 0.7 millimeter. So you can write this one 0.35 into 10 to the power minus 3 whole square. That is area of cross section into that Young's modulus value for that string or the material of the string. He has very clearly given that Young's modulus of the material of the wire is equal to 7 into 10 power 10. So write this one 7 into 10 to the power 10. This is now going to be the elongation produced or the increased length of that string when the body is just making revolutions along the circular path of radius r. So what is this value? If you simplify this one, you will get 1.67 into 10 power minus 3 you get. 1.67 into 10 to the power minus 3, right, meter you be get. So if you just look at this value, it is exactly the very first option given in the problem. Therefore, we can say the answer for this one as A. Only thing you should understand here is how to just calculate this force. That force is not simply mg. We just have to go for the components of tension. That tension itself is to be taken as the force over there. That is the only aspect which we have to understand out of it. And the correct option for this one is 1.67 into 10 power minus 3 meter. That is the very first option for this problem. Check the next number, that is problem 13. A metal cube of side length 8 centimeter has its upper surface displaced with respect to the bottom by 0.1 millimeter when a tangential force of 4 into 10 power 9 Newton is applied at the top with the bottom surface fixed. The rigidity modulus of the material of the cube is how much? The options are given this way: 4 into 10 power 9 Newton per meter square, the first option; 5 into 10 power 14 Newton per meter square, the second option; 8 into 10 power 9 Newton per meter square, the third option; and 1 into 10 power 8 Newton per meter square, the fourth option. What he is just discussing here, just look at in this figure. There is a cube like this. A tangential force F is applied at the top without changing or moving this bottom of it. Due to that, there is a deformation in the topmost layers of this cube. That if I take this one as A, B, C, D, the cube like, A is now going to A dash and B is now going to B dash, making an angle theta over here. Then all of you can understand well K, the bulk modulus. It is force per unit area tangential force per unit area of cross section, by, actually speaking, we write theta. That is actually the concept. Rigidity modulus is just asking us rigidity modulus, that is eta. I repeat, rigidity modulus is equal to F by A by theta. What is the theta called here? That is called shearing strain. You can understand well rigidity modulus, shearing stress by shearing strain we can call it. That in other words, we can even write this theta as tan theta when theta is very small. That is now going to be the displacement produced by breadth of this particular cube. So you can write this one as x by b. Therefore, eta can be written as F by A divided by x by b as such. This is the official formula you have to go for. When I repeat the same this way, Fb by A into x I can write. The same equation I can rewrite it like this. That is the concept. What are the values given? You look at first. What amount of force, tangential force that has been applied? 4 into 10 power 9 Newton. He gave 4 into 10 power 9. Into the breadth means it is after all cube. All the four sides are going to have the same dimensions. We know that one very well. So length and breadth are equal here. Each length is given 8 centimeter. So you can even take this one as 8 into 10 power minus 2 meter. Divide. What is area of cross section of a cube? In fact, it is L square. L being 8 centimeter, you can write 64 into 10 power minus 4. That is area of cross section. Into what is the displacement of the topmost layer of the cube he has given. Look at that value carefully. It has been displaced with respect to the bottom by 0.1 millimeter. 0.1 into 10 power minus 3 now can be written 10 power minus 4. So this actually is the case you people have to understand. Out of that, if you simplify the total lot, you will be getting 5 into 10 to the power 14. 5 into 10 to the power 14. Right, in fact, this goes 8 times. This goes twice. 10 power minus 4 minus 4, 10 power minus 8. Going up, that becomes 17 minus 2, 10 to the power 15. So you will be getting 5 into 10 to the power 14 Newton per meter square. That is going to be the correct answer for this, which of course is tallying with the second option given to us. Therefore, the correct answer for this one is B. That is the point what we have to understand. So whenever we talk of rigidity modulus, in this particular version, you have to convert this theta, which is nearly equal to tan theta. You can understand when theta is very small, right? Limit theta tends to 0. Tan theta by theta is 1. By all practical means, we can write tan theta as theta or vice versa. So that is the point what we are taking up here. So that now can be written as x by b. That value will be written over here. That is the point we have to take up. So correct answer for 13th problem is the second option, 5 into 10 power 14 Newton per meter square. That is second option is correct. That is B. Check the next number, which is one of the excellent model questions what have been given rather based on Poisson's ratio. A rod has Poisson's ratio 0.2. If the rod suffers longitudinal strain of 2 into 10 power minus 3, then the percentage change in volume is how much? He gave 4 options once again. The first option says plus 0.12. Second option says minus 0.12. Third option is 0.28 with positive sign. And fourth option is negative of 0.28. In fact, what is this Poisson's ratio? If you just take this Poisson's ratio, We represent that one by sigma. It is lateral strain divided by longitudinal strain. Lateral strain divided by longitudinal strain. In fact, that ratio we call it as Poisson's ratio. This by formula we write delta R by R by E by L with a negative sign. For a string, when you are stretching it, its length increases, no doubt, but thickness automatically will be reduced. That means radius of cross section will be reduced. Since the increasement of length and decreasement of R, if you take them up, one is changing in the opposite way to that of the other. That is the reason why we people used to put a negative sign before that. When length increases, radius of cross section decreases, and vice versa. That is the point. So in this particular problem, sigma is given 0.2 for us, and this longitudinal strain is given 2 into 10 power minus 3. So first of all, you estimate what is the value of delta R by R. That is minus 0.2 into the other value that is given 2 into 10 power minus 3. Write that one over here, 2 into 10 power minus 3. So you can rewrite the same this way, minus 0.4 into 10 power minus 3. That is going to be the lateral strain, that is delta R by R, what we people have got according to the calculation. Fine. But he is not asking you that. He is asking you what is the percentage change in its volume. So what is general formula for volume, please? If you take general equation for volume, V is equal to pi R square L. That is the formula for volume of a rod. That's the point. Rod means generally cylindrical by nature, we people used to take up. Pi R square L, that is the volume. So if you take this equation as delta V by V, then I can write it will be twice delta R by R plus delta L by L. But all of you can understand well in this particular case, twice delta R by R is how much? You look at that one. It is twice of this much, minus 0.8 into 10 power minus 3. That is this value. Plus delta L by L, which is nothing other than longitudinal strain which has been provided to us. That's value is given 2 into 10 power minus 3. So write the same value here, 2 into 10 to the power minus 3. So what is the ultimate value you are getting now? This now becomes 1.2 into 10 power minus 3, 2 minus 0.8. This is the value with the positive sign. But he is not asking you once again simply the fractional variation in volume. He is asking you percentage change in volume he is asking. Therefore, what we just have to do, this implies delta V by V into 100. What is that value? Percentage I just want. Into 100 means this becomes 10 power minus 1. Come on, write down that value as 0.12 with positive sign. So what is the percentage variation in volume right now? It is plus 0.12%. That is the value what actually we people have got after calculation. And this value is exactly the first option provided to us. Therefore, we can say the correct answer for this one as A. That is the question what has been given as for problem 14. One of the best questions as far as Poisson's ratio that is concerned. Sometimes they may ask you instead of volume, area variation also. That is further easier than this. These are the points we have to remember. Check the next number. This has been given in almost every entrance examination in the past. The length of a wire, of a metal wire is L1 when the tension in it is F1, and L2 when the tension is F2. The natural length of the wire is how much? Options are given. F1 L1 plus F2 L2 by F1 plus F2 is first option. L2 minus L1 by F2 minus F1 the second option. F2 L1 minus F1 L2 by F2 minus F1 the third option. F1 L1 minus F2 L2 by F2 minus F1 the fourth option. This is one of the excellent models once again. What is he talking? Length of a metal wire is L1 when the tension is T1. When tension is given T1, then length is L1. Length is L1. That means what is this L1 you know? It's nothing other than the original length plus the elongation that is produced at that particular stage. That in the sense when you are attaching some weight to the end of that string to produce a tension T1 in that string, certainly that string is going to be elongated. We know that. That elongation plus the original length of that string put together is L1. So I can write if the original length as L plus elongation 1, that is the value of L1 given. So what can we write from this one now? Elongation in the first case is equal to L1 minus capital L. That is the first equation what you need to know. And when the tension is given as T2, then he said the length is L2. Then what is this L2 again? It should now be original length plus elongation when the tension is T2. So what can we write now? This elongation E2 can be written as L2 minus capital L as such. So in both the cases, we know what are the values of tensions and we know what are the corresponding values of elongations. But we know pretty well both of course, both the tensions are applied on the same metal wire. That means its Young's modulus is supposed to be a constant. So what can we understand now? Young's modulus which is FL by AE, that is a general formula. Now F, that is T1 into L by A area of cross section into E1. What is E1 here? L1 minus L. So Young's modulus when we write for the first pair, it can be T1 into L by A into L1 minus L, that is area of cross section into elongation 1. And for the second pair of values, T2 into L by A into L2 minus L. Now just look at carefully, original length okay is same, area of cross section initial value is same. Then why can't you just cross multiply this one to write T1 into L2 minus L is equal to T2 into L1 minus L, please. I just want the value of L out of that. What is it you are going to get? L you will be getting it as, now the original length it is going to be T2, that is the value of tension T2 he has given. What is the tension here given? T2 means, according to our calculation, T1 and T2, if I take, it will now be T2 L1 minus T1 L2 by T2 minus T1 I will be getting. But we know very well what are the values of tensions he has given in the problem, you see. T1 is given as F1 in the problem and T2 is given as F2. These are the values given. So automatically what will be this formula now? This now becomes F2 L1 minus F1 L2 by F2 minus F1. That is the formula which we are going to get. And this in fact like a formula, if you remember, that is better by all means. So one of the excellent model questions, very commonly asked model as well. Almost in every entrance examination, including IIT in the past, this question, the same model question has appeared. So try to recollect the methodology And remember this one thoroughly. So this particular option is coinciding with the third option given in the question. Therefore, the correct answer is going to be C for this particular problem. So this is problem number 15 what we people are having. Almost a similar model like the previous number, we people are having another question. This also has been appeared in most of the entrance examinations earlier. The length of an elastic string is A when tension is 4 Newton and B when the tension is 5 Newton. The length of the string when tension is 9 Newton is how much? Slight variation in the method of asking the question. He is just talking about when tension 1 is 4 Newton, the length is given as A. Length is given as A means what is this length officially now? It is L plus elongation. So you can write elongation 1 is equal to A minus L. That is L means original length. That's what actually we people are talking about. Now the second concept, if you take the tension is going to be 5 Newton, when it is the case, the length is given as B and this can be written as L plus E2. Therefrom, E2 can be written as B minus L. This is the elongation in the second case. What is his question you see first? When tension is becoming 9 Newton, that is the sum of these two values he has given in this particular problem. What will now be the length here? The length in the sense if I take C, then that can be written as L plus E3, that you can write E3 is going to be C minus L. That is the case. But likewise, whatever be the number of tensions he is taking up in the problem, Young's modulus for the material of the string is supposed to be constant, because same string he is taking and he is just applying tension on the same string till it breaks like. Now in this particular case, well within the elastic limit, when we are considering the same string there and we are changing the tension values over there, automatically one can say that its material will not vary. Therefore its Young's modulus remains constant. So what is going to be Young's modulus according to our calculation? The general formula is Y is equal to FL by AE. That is the general formula for Young's modulus. Y is equal to FL by A into E. F is force applied or tension created or produced. L is original length. A is area of cross section of the string and E is elongation. Now for that particular string, Young's modulus is constant, original length is constant, area of cross section is constant. Directly you can understand. So what are the things I can equate now? When Y is equal to F, that is T1 4 times L by A into E1, that is A minus L, that is equal to 5 L by A into B minus L. This is now going to be 9 into L by this time again A into C minus L. Now since Young's modulus is constant, you can now equate these three. Simply equating these two, you calculate the value of L. Equating these two and substituting that value of L, find out C. Simple. Equating these two, you calculate the value of L. Substituting that value over here, by equating these two, you find out the value of C there. What will that value of C be? He has given the options this way: 4A plus 5B the first option, 5B minus 4A the second option, 5B plus 4A that is the third option, and of course 5B minus 5A the fourth option. If you just look at that one, the second option is going to be correct here, 5B minus 5A. You get C as 5B minus 5A. So what we can understand here is the answer for this one is just the second option, which of course can be taken as B here. That is the one. So all of you just remember this methodology, and this is also one of the very commonly asked models. One thing you should understand, A is the length, means it is original length plus the elongation that is produced at that particular juncture when the tension created over there is 5 Newton. That is the concept what we have to take. That is problem number 16.